Okay, welcome. We're on half angle formula. We've done double angle, additional formulas. So from my previous video, if you've not watched that, maybe you have to go back before this half angle formula. I showed that sine 2, that's this double angle 2a is 2 sine a cos a, and cos 2a is, it has three formula, either cos square a minus sine squared a, or 2 cos squared a minus 1, or 1 minus 2 sine squared a. So the y for tan 2a is 2 tan a over 1 minus tan squared a. So these are double angle formula. So with this, let's now use it to get half angle. For half angle, instead of sine 2, I have sine a. And you can compare. This is 2a, and what I have here is a. That is, whatever that is here must be half of this. So since it's a, half of a is a over 2, so I have 2 sine half a cos half a. So for cos a, I have three formulas, either cos squared half a minus sine squared half a, or 2 cos squared half a minus 1, or 1 minus 2 sine squared half a. So cos a has these three half angle formulas. Y tan a is now 2 tan half a over 1 minus tan squared half a. So these are my half angle formulas, but we can still get some unique formula from this. From this, we can get something. Yes, we can see that okay. With this, let's now solve some question on that. Okay, we're asked to find the value of, what is the value of sine 15 squared cos 15 squared, this, so okay, let's solve. So the first one, sine 15 square cos 15 square, so we can write this as sine, remember that square is here, so I can bring the twos together, all squared. Very correct. And this sine 15 cos 15, we can write it as sine 30 over 2. Yes, because from our double angle, because from our half angle, because sine a, from our half angle formula, sine a is 2 sine a over 2 cos a over 2. So if a is 30, so I have 2 sine 15 cos 15. So if I make sine 15 cos 15 the subject of formula, is now sine a over 2. So that's how we got this, all squared. Do you get the logic? So if I make, okay, if I make, implies that if I make sine half a cos half a the subject of formula, what I will have now is sine a over 2. So do you see why? Sine 15 cos 15 is sine 30 because 15 is 30 over 2. So with that, sine 30 is half. We can get this value fast. So with this, therefore, this is now sine 30 is half over half all squared. This is 1 over 4 all squared, which is 1 over 16. So our answer is option B. So we don't need a calculator for that. So that same way, we're asked to find sine squared 22 and a half minus cos squared 22 and a half. We know we can write this as, if I factor minus, I'll write this as cos squared 22 and a half minus sine squared 22 and a half. Yes, because I want to bring in half angle cosine, and we can write this as minus cos squared half. You know, this like cos squared 45 over 2. That's half 22 and a half sine squared 45 over 2. So we can write this as minus cos 45. Yes, because of from our double and from our half angle, see it, cos A, cos squared half A minus sine squared half A. So if A is 45, I have 45 over 2, 45 over 2. So that's why I said it's cos 45. The minus is because of this minus sign, so which is minus cos 45 is root 2 over 2. So this is option B. So it's a very nice question. Coming to this one, the same cosine half angle, if you could remember, we have that cos A is 2 cos squared half A minus 1. Yes, let's go back so that you see it. Cos A is 2 cos squared half A minus 1. So let's go back and finish the equation. So implies that if I make cos A the subject of formula, cos half A the subject of formula, making cos half A, so 1 goes here to be, okay, maybe let me do it here. Since cos A is 2 cos squared half A minus 1, if I make cos this A over 2 the subject of formula cos half A, so 1 goes here to be 1 plus cos A divided by 2 after in square root. So that's it. Again, sine, since cos A is 1 minus 2 sine squared half A, so if I make sine A over 2 the subject of formula is now 1 minus cos A over 2 all in square root. So I'm going to use it here. So I'm saying that cos A over 2 is now square root 1 plus cos A all over 2. So if you now put cos, that's 15. 15 means 30 over 2. So which is now square root 1 plus cos 30 over 2. And cos 30 is root 3 over 2. So let's continue. So I'm saying let's continue. I said that cos 15, which is now 30 over 2, is equal to square root of 1 plus cos 30 over 2, which is square root of 1 plus cos 30 degrees is root 3 over 2, all over 2, which is the LCM. That's this is 4 now. 2 plus root 3. So finally, square root of 4 is 2. Why this has no power square root, which is 2 plus root 3. Cos 15 is positive now, so it's positive. So our answer is C. As you can see, is C. So the answer is C. So the next question, they say show that this is that. Okay. So we'll start by, I'm seeing addition formula. I'm going to use addition formula here. So I have sine alpha plus sine beta. So I know that sine alpha plus beta is sine alpha cos beta plus cos alpha sine beta. So if you've not watched my sine alpha plus sine beta plus sine alpha cos beta plus cos alpha sine beta. So which is equal to, we open up this. So I have sine alpha plus sine beta minus sine alpha cos beta minus cos alpha sine beta. I just opened the bracket over. I repeat sine alpha plus sine beta plus sine alpha cos beta plus cos alpha sine beta. So the next thing is to collect, as you can see, we'll factor this and this. So if I factor sine alpha, so I'm left with 1 minus cos beta here. Do you get? Both have sine alpha factor plus this and this have sine beta. So I have plus sine beta. I have 1 minus cos alpha. I factored sine beta in this and this and this. So over the same way, I factor sine alpha, this and this, but this is now 1 plus cos beta plus sine beta 1 plus cos alpha. So we are still solving. So remember, we are to convert this to half angle, so we're going to use half angle formula. So for sine alpha, if you could remember what I just taught now, that sine A is this, so I'm going to use it, and cos. So here you now see that this could be written as 2 sine half alpha cos half alpha. That's for this times 1 minus cos beta will be 1 minus is now equal to 2 sine squared half beta. Yes, because if you if you see, sine half a is now 1 minus, that's 1 minus, oh, is okay, let's use this one. Making sine squared half a the subject of formula is now 1 minus cos a. So that's the identity I used here. So that's why it's so. Y for this plus sine beta, we can write it as 2 sine half beta cos half beta times 1 minus cos alpha is now 2 sine squared half alpha. So this is my numerator. Y denominator, we use the same thing, which is 2 sine half alpha cos half alpha times 1 plus cos beta. Plus is now cosine, so I have 2 cos squared beta over 2 plus sine beta is now 2 sine half beta cos half beta times 1 plus cos alpha is 2 plus is the same cosine, so 2 cos squared half alpha. So this is my, remember this times that. So let's continue. Okay, so let's continue. So we can multiply this times this is 4. That's 2 times 2 is 4. I have half alpha cos half, so write sine half alpha cos half alpha sine squared half beta. So I've multiplied this and this plus this times 2 times 2 is 4. So I still have sine beta over 2 cos beta over 2 sine squared alpha over 2. So that's the numerator. Why the denominator? 2 times 2 is 4 cos sine half alpha cos half alpha cos squared half beta plus this times that is 4 sine beta half beta cos half beta cos squared alpha over 2. So as you can see, there are some common terms here like 4, 4, 4, 4. And if you look at this, for again, if you look at, there is sine half alpha here, there is sine half alpha here, there is sine half beta here, there is sine half beta. So let's check again here. There is sine half alpha in both. Okay, no. What is common? Okay, we can factor. Okay, let's write it. 4 is common, 4, 4. So sine half alpha is common. Sine half alpha and sine half beta. So sine half beta is common. So what we are left with is this is out, this is half. This is what is left here is cos half alpha sine half beta plus we brought out 4, we brought out sine half alpha, So remaining one sine half alpha. We brought out sine half beta, remaining cos half beta all over. So the same way we'll bring out 4. So what is common? Cos half alpha is common and cos half beta is what? So cos half alpha cos half beta is common. So we are left with here, we are left with sine half alpha and cos half beta plus, so again we are left with sine half beta and cos half alpha. So what do you notice? This and this are the same. See, sine half alpha cos half beta plus sine half beta cos half alpha cos half. So it's going. So we are left with 4 4. So we are left with sine half alpha sine half beta over cos half alpha cos half beta, and as you can see, sine over cos is tan, so we have tan half alpha, while sine over cos is tan again, that's tan half beta. So we've proved that. So it's a very tricky question, very tricky.